video, B.3, we will understand the asymptotic notation concepts using graphs of functions to see visually for better understanding. All right, so first, let's look at the big O notation. We just learned the big O notation, right? Upper bound, remember, we use C constant multiple, big O. All right, so here let me just put, big O notation of G of n. The meaning, there exists some constant C in this way, also we have this, All right. So what's the meaning of that? So on the graph, we can draw in this way. So this is the graph of f of n. All right. G of n, so we do not draw the G of n, but we draw C constant multiple of G of n. We can choose an appropriate positive constant C of G of n such that after some special line, n0, after that vertical n0 line, n equals n0. So this is the function, this is the representation of this vertical line. After n pass this vertical line, then f of function has an upper bound. C times G of n is an upper bound of f of n. So that's the meaning. From the graph you can see. F of n is under, the graph of f of n is under the graph of C G of n. But the left hand side of the vertical line, it doesn't matter. Which one is larger, which one smaller, it doesn't matter. So even you may have things like that, don't worry. We don't look at that part, because that part affected by the overhead, right? The overhead affected the part. So we're fine. We don't treat that part seriously. We ignore that part. Okay? All right, so now after that line, so then we can see the trend. We can see this upper bound trend. See? That's the meaning. All right, so this is the big O notation. Our asymptotic notation number 5, big omega notation. Big omega notation. We learned a little omega, infinity, right? The ratio goes to infinity. Infinity. But big omega, what's the meaning of the big omega? All right. Meaning is this. For a given function g of n, the notation big omega of g of n represents the set of functions f of n that satisfy the following condition, lower bound condition. Everything is the same. The same compare with big O notation. Only difference is this time we use the lower bound. Change from upper bound to lower bound. See? The view is different. So we look at different things. The view is different. Lower bound. For all n greater or equal to n0. The role of n0, the same as before. We understand that. We understand the line here. All right. So that's the big omega notation. Then the last one. So let's look at the graph first. Then the last one. The graph similar to big O notation, but this time we put C times G as the lower bound. Its graph below the graph of f of n. After that vertical line, n equals n0, that vertical line. See? Yeah. All right. Yeah. So that's the meaning. Yeah. Our asymptotic notation number 5. So this is our number 5. Yeah. All right. The last one is the, oh, what's that? The last one, we learned this before, big theta notation, right? Yeah. But here we just, use the formal language to describe it. Then use the graph to view it. That's it. Yeah. Definition. Still, yeah, so we use, same language as our previous 2 definitions. But this time when we choose positive constant, we have C1 and C2. Also, same N0 we used before. Yeah. Then we have both upper bound and the lower bound. Yeah. Yeah. Then in our graph, so when we draw the graph, something like we combine big O case and a big omega case, because both upper bound C1 G of n and the lower bound C2 G of n. See? Yeah. Yeah. So those definitions, here we see 5 asymptotic notation definitions. Pretty abstract, right? Pretty abstract. Yeah. But if you can use your imagination to understand them graphically, yeah, so in your mind you can establish the graphs, things like these things, the graphs. So you can get a, faster understanding. Yeah. You can imagine, you can get a faster understanding. Yeah. All right, so that's our B.3 video. Next one, I want to show you several examples related to asymptotic notations. Yeah. Typically, when we work on those examples, we use 2 ways. The first way, the limit way, we calculate the limits. 0, positive, non-zero, positive constant. Yeah, let's just say positive constant. So then we do not need to say non-zero, right? Positive, that must be non-zero. Yeah. Positive constant and infinity. Yeah, the limits cases, 3 cases. Then upper bound, lower bound. Yeah. So, yeah, in next video, that's the last video for this class. I will give you many examples. All right, so let's stop here first.